Let's go to the National Electric Code. And we're looking at Chapter 5 here. Chapter 5 has three major parts, Chris. One part is conduit fill, the other part is box fill, and the third part is going to be the pull box fill. The pull box fill. And I'm going to take them one part at a time. Okay, so let's go directly into Chapter 9. Please, if you guys go with your friend Chad to Chapter 9. When you have a conduit like this, to ensure that you're looking at right here, when you fill the conduit, guys, there's a few things that you have to keep in mind. If you have not highlighted this table, Chapter 9, Table 8, if you have not highlighted this table, please do so. We have a conduit. Either you have one conductor in the conduit, two conductors, or more than two. You can look at the one that I'm holding right here in my hand, it has tons of them. So that's very important table. So what you're going to do with your friend Chad, you're going to go here. Okay, where am I here? Mark. Highlight text. Okay, so the first thing I would like you guys to do is to highlight this table if you have not done that. This is very, very important table to highlight. So if you have one cable or one conduit, so I'm sure some of you are looking at PVC. How would you have one conductor cable? Imagine a 2000 kcm. Can you put 5 2000 kcm in one conduit? Can you? You can find a conduit that fits this. So if your conductors are huge, you can put them in PVC one conductor at a time. Remember that heat, induction heat, you're going to be very careful when you do that. So bigger conductors in PVC, one metallic, no problem. You can put them one conductor at a time. That's one option. Second, remember if you have a multi-conductor cable. Can we have a multi-conductor cable? 4 conductors, multi-conductor cable, 4 conductors, 4 out, one assembled cable. Can I do that? How would you treat a multi-conductor cable? You treat it as one conductor and you fill 53%. 99% of the time, Chris will be filling at 40%. Everybody okay with that? If you have not highlighted this, please do so. So this is one of the most important things that we have to highlight and make sure moving forward I want you guys to highlight it. There's a couple of information, guys, I'd like to highlight pulling. This note right here, it will tell you right at the second city, if you fill this, when you become now bigger, commercial, when you fill according to this, you're going to be able to pull these conductors easily. So pay attention also to the friction in the conductor. So it allows you to pull conductors or cables into a raceway. When pulling conductors, if the ratio of the raceway inside diameter to the conductor cable is between 2.8 and 3.2, jamming can occur. Phil, there's a software that we have that actually takes into consideration the jamming effect. So anyway, when you guys go advanced, you're going to this one. For the time being, why don't you highlight this little jamming effect here for me? Jamming effect. Very few people pay attention to what I'm saying what I'm doing. So okay, so that's the most important thing. Another note I want you guys to highlight is note number 3 right here, number 4, and it talks about nipples. Nipples, 24 inches or less, you can fill them up to 60%. So please, this is where, wait till if you have a piece of plywood like this one, 24 inches or less, I can fill this building up to 100%. Why? When do you can fill it more? It's easy to install them, not have a lot of travel heat. You don't try to heat them much easier to install with a short piece of conduit. Did you guys highlight this one? So if you have do so. Okay, another one, conductors not included, okay, such as multi-conductor. This one is very interesting note. This will tell you if you're using a multi-conductor cable right here, multi-conductor cable in fiber optics, how would you use a fiber optics in PVC configuration? This is, we have it on the German master exam all the time, guys. If you're sitting for a German exam, here's how to test you. They'll tell you how many fiber optic cables you can fit in a 2-inch or a 4-inch PVC Schedule 40 if the diameter is a 1/4 inch. Then you have to do your calculation from the diameter. What do you do from the diameter? You find the cross-sectional area, right? Pi r squared, that's the cross-sectional area of a circuit. and you continue doing the same calculation. So only difference between a cable and a conductor is you take the cross-sectional area pi times r radius, squared the radius multiplied by pi, 2 pi r squared, right? 2 pi r squared, that will give you the radius. And when you get the the area, when you get the area, you continue with the same calculation. So this is what it goes to. If you have a multi-conductor cable, which we will be, guys, you will be using a multi-conductor cable. What you're looking at right here, what you're looking at, very clear, a difference between a multi-conductor cable and a single conductor cable. What you're looking at here is a 4 single conductor cables. If I put these 4 in one jacketed assembly, and I pull them in a conduit, this becomes act as one multi-conductor cable. Does that make sense? And we use that all the time, and cables are great with MC cable or AC cable or assembling multiple conductors in one cable. 90% of the time, you guys will use a single conductor cable like this. So we are 4 single conductor cables. But if I put them all in one jacketed material, assemble them and pull them in a conductor, becomes one multi-conductor cable with 4 conductors in it. Very important. And filling, we know that one when we start doing power system analysis, the difference between a single conductor cable and a multi-conductor cable. Big deal. A single conductor cable, aka, is a wire, conductor, just one wire. Okay, so highlight this one, please, if you have not done so. So these are important. Okay, so I'm going to pick the most important one. Number 7 for you guys. Number 7 is good. Here's what I wanted to highlight in number 7. Right here. Highlight this one. This, if you read it, it tells you how many conductors can you fit in this conduit. So Chris, I did my calculation, end up with 9.7. Can I go to 10 or can I go to 9? Look at this note. It says if it's 0.8 or more, what do? Go up. So 9.7 becomes 9. How about 9.8? Becomes 10. Okay? You can see how many conductors you can fit in the conduit. Different sizes. That's where there are different sizes. You look at the fraction. If the fraction is 1.5, as we always did, if the fraction is 0.8 or higher, you go up. Anyways, this is also another stuff that they use a lot for their master or German exam here, at least with this one. And the last one, guys, here, look at this. If you read this, it will tell you a multi-conductor cable or flexible cord or 2 or more conductors shall be treated as a single conductor for calculating percentage conduit fill area. Before assembling in one cable, now you treat them as one single cable when you pull them through, so you can fill it. You can fill it. If I put one cable, 4 conductors, one cable, my fill will be 50%. Right? Because it's one conductor or one cable. Remember that right here? One conductor or one cable. My fill will be 50% if these were assembled in a cable, which they are not. Cool? So here I'm going to make sure, guys, very important concept. You can't move forward without knowing these notes. Any question? Any question? Okay. So this is idea why they drop it so much for this tool. Over 253. 2 is 31%. Yeah. What's the rationale? 3 is 40. Yeah. Why more than 2 is better than 2? Yeah. Yeah. When would you use a 2-conductor DC system? 2-conductor cable. Looking at that, when would you use a 2 conductors only? I guess you can use it for, you can use it for single phase. How often do you use 2 conductors in a conduit? Really? Just 2 conductors in a conduit? We could. What's the rationale? Yeah, I see what you mean. What's the rationale? I don't know. The only thing you can think of it, the rationale for always is 2 things. Number 1 is jamming, and number 2 is being able to move the conductors without overheating and so forth. So it seems It seems if you have two conductors, it could increase the jamming a little bit more than 3. It's the only thing I can think of. Good point though. Okay, a third one, guys, I want you to do, if you have a bare conductor, God forbid putting bare conductor, make sure you go to table number 8, right? Table bare conductors. The cross-sectional area of bare conductors is number 8. And the cross-sectional area of insulated conductors, it's going to be from table number 5 or table number 5A. And dimensional conductor is going to be table number 4. Okay, so we're going to be using these in a second. Really, the most important things is the stuff that I did a minute ago. Okay, moving forward. When we do, if your conductors, you use table number 4, guys, to find the fill for the percentage of the fill or the cross-section area that you can fill in all the approved conduits in the US, that we at least use in the code. If the conduit is not here, you have to do a different engineering calculation. So I'm going to use all the conduits that we use, guys, are here. All the conduits are basically here. So let's use EMT. Can you guys see it? So table number 4 gives you the fill for all the conductors. With an EMT, this is probably you spend most of your time writing this table. Most of your time. Cool? I'm on this table. So how does this table work? If I have, let's go to the largest conduit I can buy as an EMT, which is 4. If I am pulling, which 99% of the time I'm going to be right in here, right? 40%, then I can fill up to 5.901 square inches out of this cross-sectional area of that conduit. Everybody knows how to use that? So that's basically the only time. So when so this is going to be, I would say 90% of your time you're going to be right in here. Right, 90% of your time you're going to be right in here. Okay, now when would you be here? This one is also if you have a conduit 24 inches or less. Special cases, very special case, conduit 24 inches or less, you're going to use this calculator. I want to bring to your attention, guys, look at that. If the conduit, look how much you can fill it. Can you see how much you can fill the conduit if it's small, 24 inches or less? 8.852 compared to 5.901. You can put 3 more inches almost, right? Almost 3 more inches, square inches, into a conduit if it's short. Anybody knows why if it's short? Easy to pull things in it, easy to take, maintain. When you put conductors in the conduit, the assumption, Nick, is 2 things. Number 1, you'll be able to install them easily without damaging the insulation. Number 2, you need to retract them easily, pull them out upon failure or if needed, add into the conduit if you accounted for that, easy to, and of course the heat interaction between all these conductors. It's not going to heat up the conductor insulation to a point where it's going to deteriorate. Any question is what this table? If you don't know how to use this table, you're doomed. Now, thanks to the calculator. I want to remind you guys right now, for the ones who have the electrical calculator here, electrical calculator only give you the 90% of this. So, Chris, disclaimer, if you will go to the nipple here, the 24 inches, at least I couldn't figure out how to do it on the calculator yet. I don't think you can do it. Okay, so Phil, who cares? I can cover 90%. 90%, guys, is a big deal. You can pass your German exam master and registered engineer with 70%. So if you can cover 90% of your work, is that bad? For all the conduits, it's not bad. These 10% will let Zach take care of it. Okay? So the only for 10% you will be doing probably calculation by hand. Any question, guys? Any question? The second one is by half. And if you go all the way to the half as a nipple, is what you get, and as also a cross-section area, 3/2 conductors here, which we get. Now the question would be, when would I use the 2? When would I use the 1 and the 2? When would I use the 1 and the 2? Have you ever guys asked Gary or any of our instructors, Zach, went over 1 conductor or 2 conductors? I said, this is 90% of the time you're in here. When would you use a 1 conductor cable? Two reasons. Number one, if it's have a multi-conductor cable with multi-conductors, so here's my one. Or if it's one conductor cable huge, 2,000 kcm, you can't pull 2,000 kcm in a conduit. Are you kidding me? You can't find a conduit big enough for that one. And so that's where we would use very special condition. And number two, guys, the same thing. If you have two cables or DC system, two conductors, big cables, put them in one conduit. I always think of it as multi-conductor cable. Two multi-conductor cables. You have one cable for conductors and another cable for conductors. Feed them from somewhere. The worst thing we would ever do if you put two meters in one conduit, set them, from a design point of view. Any question, guys? Everybody knows that 90%? Now, Ashley, my friend, if you go down, you will find all the approved conduits and their fill. So your ear, nose, and throat doctor is here, ENT, right? That's like your ENT doctor is here, the conduit, and all the other conduits are directly into that table. So I highlighted only I highlight only number 4 for EMT because it's the most common. Okay, moving on. You guys see the flex? All the way, keep moving. IMC. All the conduits approved is right in here. Now, Chris, all the conduits that you're looking in these tables are where? In this miscalculator. All the conduits that you're going to use right here in this table are where? In this electrical calculator. So that's really cool. Okay, moving on. PVC, as you move through, I want to highlight the most important ones, guys, as we move through it. So PVC, you must know PVC. I mean, this is must know. This is another well-respected conduit. PVC Schedule 40. If you haven't highlighted that one, please do so. You're going to use it. Did we pass rigid? Yeah, rigid. For hazardous location, please highlight rigid too, because you're going to be using rigid. Intermediate liquid type flexible metallic conduit, also used we only use it to tie to equipment, liquid type flexible metallic conduit. So these are, okay, moving on, all the way we highlighted rigid type A PVC. These are the most, I'm just highlighting the most important ones. Okay, that's it. These are the most important. In the second table that you need to know and highlight, if you have not done that, is table number 5. Any question guys about the conduit fill? When we do the conduit fill, define the cross-section area under the right tile. Am I going too fast of that one? Okay, so highlight them, make sure you know them. You're not going to hear me saying too much about them in details over the whole year. Later on, we start saying, I have a feeder, I want you to go size the conduit for me. Second nature to you. You're going to go, which conduit, Chad? Well, you're the designer. 99% of the time, you're going to be EMT. If you're underground, you're PVC. If you're hazardous location, you're going to use rigid. Or physical protection, you need rigid. That's it, done. If you're tying to equipment that vibrates or light, what do you need? Flex. What type of flex, Chad? Flexible metallic conduit, indoor, outdoor, liquid type. Done. It's all the conduit that you need. There's a lot of other conduits have their own deal, but these are the most important ones. Okay, moving on. To use this table, guys, it's interesting. Let me just tell you interesting about this table. There's a few things. Number one, the type. You need to understand the type of the insulation here. You need to understand the size. I hope so. You need also the square inches, unless you're working in Europe and you use the square millimeter. The diameter is not a big deal, but these are the most 3 things in this table. Okay, let's take this. Suppose I have an RHW insulation, RHW, and suppose my conductor was 600. Are you guys okay with that? 600. What's the cross-sectional area of this conductor that I can use for conduit fill? Right here. If you don't know this table, please get used to it. Another example. Suppose my conductor is RHW2 insulation, right? And suppose the size that I'm using is 4/0. So the cross-sectional area for my calculation is 0.4754. Everybody knows how to use this table? We're cool? That's it. It's as easy as that. Now it gets easier, Phil, You don't have to even worry about that. Look at your friend, the calculator now. All this information has been input in the calculator, and you can pull them direct for every size in any single. Isn't that cool or what? So it takes the time out of going to the tables. There are two ways of doing things. Number one, you have to do it right. Everybody has to do it right, or you're out of business. Get the heck out of there. You don't belong. You don't do it right, right? Number two, Chris, you have to do it right, and you have to do it fast. Because if you don't do it fast, you're not going to make any money. I'm sorry. As a contractor, you have to do it right first, and then you have to do it fast. And of course, safe. I always say when I do the apprenticeship, safe is a big deal for us. You have to do it right, you have to do it safe, and you have to do it fast to make money for your employer and yourself. But if it takes you, Nick, that's where these gadgets become really cool. It makes you go things fast, hopefully, Chris, and now Chris doesn't agree with me. The rest of the time you go golf or you go deer hunting or bear hunting, like Ashley would do other things. Okay, let's keep going with table number 5. I'm going to highlight this calculator, guys. Take the most, very important when we use it. It doesn't take all the insulation. It only takes the most common insulations. THHN, THW, and XHHW and XHH. These are the most common insulation. Between these insulation, THHN, XHH and XHHW and THW and THHW, between these 4 insulation, guys, you probably covered 90% of what you need in a building. Only 90%. The other 10%, you have to refer to the table. Like, for example, if you're looking at RHH.HH here, please don't look at it. It's not there. Special type of insulation. 99% of the time, guys, you're going to be using THH and THHW or XHHW or XSH. XHH, XHHW. So these are the most common insulation. Okay? I think that when they put the X, they all rated for 90 degree from a derating purpose. To find that definition of all these guys, remember table 310.10. Yeah. I don't want to know where I am on my computer now. Okay. Yeah. So it's going to be 3. They're all the same, but it's rated for 90 degrees. That's why the difference between, for example, THHW. So X, where's the X? You got THHW, X, where's my X here? On page 119. Yours is going to be different than mine is slightly here. Okay, so I have, this will be only on page 310.104 with the definition THHN, THHW, THW, these are the most common, and we say XHHW and XHH is the thermoset, but they're all thermoset though, a heat resistance thermoset. This one is just thermoset. The key point for the X, when we put an X on them, the really rating point is rated for 90 degrees. Especially in a wet location. Okay, any question guys about this? So let's go highlight a few things here. Let's go highlight the most common ones. Here you go. THHN. Look at let's go bigger THHN. I would look at here's my THHN, guys. Take this. I have a 400 amp panel. I have a 400 amp panel, right? 400 amp panel, and I'm going to feed it from a THHN conductor to a location. I'm going to use a 500 kcm. 500 kcm give me 380. 380, you can tie it easily on a 400 amp. So 500 amp panel fit from 4 conductors, 3 pairs, 500 kcm each. And I'm going to slice the conduit for it. So here's my 500 kcm. Here's my THHN. And can you guys see the conduit for THHN? Oops, there you go. So I have 0.7073. So what do? You multiply by 4 and go find yourself what type of conduit you have. EMT, and under which column? 40 degree column, and find yourself a conduit. Okay, let's do that example quick here, guys. Here's my panel. Here's my 400 amp panel. I need to tie my 400 amp panel. The feeder that feeds my 400 amp panel, this is feed N. I have 4 conductors, I'm not derating, 500 kcm, and I need to size the conduit. EMT. You guys have any issue with that? 4 conductors. Let's do it. Here's the number that you need. I need somebody with calculator, please. So take 0.7073, multiply this by 4 of them. Who's my calculator for the day is going to get a 10 out of 10 in participation? What is it?
So the area on the cable using THHN is 2.829.
And 2.829.
That's the area you need.
That's the area of the conductors, right? So all the conductors multiplied by their number give you the cross-section area added together. This will be a square inch. Okay? Any questions about this? We got square inch. Then next, what do you do next? I want you guys to remember the number. You have the number, right? Everybody knows how to take this number multiplied by 4. Later on, we'll be doing through a calculator right on the spot. Okay? And I will do it in a second here. Let me take a snapshot of it so it can get out of this. So let's go find a conduit right on the spot. We're going to go back to EMT conduit, back to EMT conduit. You guys remember my beautiful EMT conduit? Back to EMT conduit. There you go. Went too far. Back to EMT conduit. Okay, so press. Remember what was the number that we're looking? Here's my EMT conduit.
2.829.
My EMT conduit is here. It's all the conductors are 2.829. So under which there's how many of them? I have 4, so I have to go right here and under the cross-section area, and I need to find a number that's equal or higher than that one. So let's go. So I have 2.8, 2.8, 2.3, again 2. That's all. I need this number, right? Am I right? I can't use 2.3 because it's low. If you cross-reference this number, that will get you to conduit number 3. Let's use the calculator. How about that? Shall we? Let's use the calculator for that one. So number 3. Okay, get your calculator handy. So we did that one. Get your calculator handy. And let's go do it with our calculator. And hold your horses for a second with your friend Chad. Remember what we said? Okay. The first thing I will do, are you guys defaulted to, since it's 3-phase, I always like to default to 75. So make sure calculator 2011, 3-phase, 75 copper. Cool? Everybody set at that by doing set 7 and set your calculator. Cool. How many conductors? So just a quick reminder, guys, we were 4 conductors and 500 kcm, and the conduit is EMT, and we came up with 3 inch. Let's see if we came up with the same 3 inch here for your conductors. Okay, with me. Let's start here. First, the conductor size. You're going to go 500, right? 500. Everybody's okay with that? For the kilo, hit the word kilo. So I have 500 kilo. Kilo what? Kilo Chad or kilo dollar. Up to this point, it doesn't really know what kilo what. So we're going to go from the kilo to wire size. See where it says wire size? Now I have just assigned a 500 kcm copper to the calculator. Everybody's okay with that? 500 K wire size. Cool? Everybody's okay with that? Wire size right here. Wire size. Everybody got that one? Cool. Now, how many of them Phil do I have? 4. Let's start 4. 4. What installation? THHN. Do you guys see the installation way at the top here? Everybody see the installation? 4. So I have assigned 4 conductors THHN. 500 kcm each. That's what I did told the calculator. Now what do I need next? Conduit. Everybody knows how to assign the number of the conductors. You type the number and then the type of the installation. I will remind you guys we're limited to the 90%. The installation that you use 90% of the time. You have THHN and THW and XHHW. So these are the installation that you're limited to. Okay, everybody's there? Cool? Cool? Let's go find the conduit size. When you're going to go find the conduit size, you're going to grab, look at this, you're going to grab set, you're going to hit, you're going to hit conduit, hit right away conduit size right here. So I have 3 inch. Hit the conduit size right in 3 inch. Now, is that easy or what? 3 inch. Now I know these are all the same size, so we could have gone to Annex C later on. But you can do it with different sizes too. That's the beauty of it. Different sizes. We'll do it in a second. Any question, guys? Rob, I decided to change it to PVC. You guys have a problem with that? I changed my mind. I need PVC Schedule 40 on the spot. Here's what you do. You're going to go set and hit conduit. This is EMT. We don't have EMT enough for this baby. Then set conduit. This is FMC, right? Still 3 set conduit. IMC still rigid. See how nice it moves you through all the conduits just by hitting set conduit. Liquid flexible. No size for that. For this size. The same thing here. Liquid flexible non-metallic. The same thing. There is no size, so keep doing. Keep clicking. I'll give you here's a liquid tight flexible metallic conduit. Number 3, still number 3. We need rigid though. Set. Did I click on? Okay, here's PVC Schedule 80. 3.5. Now we need 40 though. So set and conduit. We need 3 inch PVC. So if it was Schedule 80, it makes sense. Do you guys know the difference between 80 and 40? The outside diameter stays the same, right, Zach? What changes? Inside diameter is thicker. So when Chad is mad and he kicks the conduit, not kick it, or grab his hammer and hit that conduit, it doesn't bust right through the conductor. So it makes sense that the PVC Schedule 80 is bigger than Schedule 40. Any question is? Kyle, my friend, do you see the beauty of it? Okay. Any question? So right on the spot, a couple of clicks, and you're up and running. All right. So any questions? So we have one example. We'll take another example, guys, with different sizes in a second here. Take a couple of examples with different sizes. Okay. Let's take a snapshot here and exit this so I can keep moving. I'm going to move my calculator to the side so it doesn't interfere with my business. Okay, so any question, guys? Here's my EMT all the way. So let's do another example. And Chris, I need your help with this example. Let's use let's go back to, there you go, back to a real installation. PVC Schedule 80. We'll take a real example, guys, with THHW. Okay, do I have THHW? Yup, THHW. We have THHW. Yup, THHW. Okay. All right, here we go. I need, here's the following. This is real example. We're going to encounter it all the time. Okay? Take this. I have a panel. My panel is, let's say 400 amp, and you are sizing the conductor for this 400 amp panel. I derated the neutral this time. I can't derate the neutral. So here's what I got. And take this. I got my 500 kcm, 3 conductors, 500 kcm, THHW, because we're going underground. Typical. You're going underground in W, right? 1, 2. We have a 1 neutral, derate neutral. You can derate your neutral. No problem. You can derate your neutral. Usually, when we do the calculation, end up with 1 or 2 steps below the phase. So I have 500. I can probably go all the way to 400 with my calculation. I have a 400 kcm neutral, the same thing, THHW. The conduit that I want, Ashley, my friend, is a PVC conduit, because I'm coming underground. Conduit of choice is PVC Schedule 80. Conduit of choice. Can I use rigid? Bring it on. Can I use EMT underground? Yeah, but you will not be smart. You can. But It's not a good idea. It's going to rust. Can I use rigid? Yes, you can, but it will rust over time. The best conduit for the application underground is what? PVC Schedule 14. Can I use ADS? But you will be, if it's buried, what's the likelihood that Chad is going to hit that conduit with his hammer? No. Okay, so, and I need one conductor, ground. And I'm going to go size my ground conductor. It's supposed to, let's suppose that this table, guys, let's go to 250. Let me get my rounded size here. What would you? And we will do that. Okay, so this is 400 and I need a number 3. So I need a conductor number 3, the same thing, THHW. So here's these are the 3 pairs. This one the neutral, and this is the ground. The equipment grounding conductor. Let's use the terminology that they could use. Cool. Typical feeder that you utilize as an engineer and a designer. Typical feeder. Any questions about that? So let's go size the conduit. That's more typical than the example I gave you. They're different sizes. Okay. So they're all THHN. So here's I have the 500. Are you guys looking at the 500? Here's my 500 here. So I'm going to multiply this by how many? By 3. You guys have any issue with that? Then I'm going to go to the 400. We have 500 here. I'm going to go to 400 right underneath it. And what's that one? Right here. And I multiply this by what? 1. And what's the number 3? I'm going to go to number 3. And this one would be here, right? And I'm going to multiply this by 1. And Chris, can you do me the math? Any 2 people guys doing the math, I give me the answer. Typical, right? I pick them directly and do the math. Multiply, add. 3.146. I need another gentleman or lady to agree. 46. Okay. All right. This is 4 inch. Okay. Cool. Everybody's okay with that? All right. Now I don't want to leave this view, so I want you guys to go to a table. Now PVC. Let's take a snapshot and leave it. Who cares? Take a snapshot. So Chris reminded me of 3.146, and we're looking at what type of conduit chair that we're looking at. We're looking at a conduit PVC Schedule 40. And the question is, what size? What size do I need PVC Schedule 40? What size do I need PVC Schedule 40? Okay? Cool? All right. Everybody got that one? Straightforward. Do your math. All right. So let's go X here, so I can go all the way up. And I'm going to go. You guys are going with me, right? Probably faster. What did they say? PVC Schedule 40. Wow. I can't be better than that. Chris, remind me again. What was that? 3.146 square inch, right? Okay, so here's my number. Under which column? This column. And I'm going to go look at 3.2.93. So this is my baby. 1, 2, 3, 4. You can go 1, 2, 3, 4. And I have 3.5. Is it 3.5? Yeah. Right? Did I do it right? 3.5. 3.5. 3.5. I need question as a 3.5. I need 3.5. Let's go do it with a calculator now. 3.5. Let's do that one. So we came up with a size of 3.5. Let us minimize this and open my technology. Okay, Chad, where are we here? Right here. And grab the calculator, which is sitting to the side. Okay, so I thought I got this one here. This is the example that we did, right? Yep, right in here. And I want to put it in a place where I can see the example. Okay, right here. All right, so here's my example. I have 3 500 kcl, 1 400, and 1 3. Let's do it. Cool. Go clear your calculator. Make sure you clear. Double click on the clean. Your calculator is clean, right? We're going to start with the 500 fill. So what do you do with the 500? You're going to type 500, and it's a K, not KCHN, it's KCM, so K wire. So I have 500 copper. And you can change to aluminum, it doesn't make a whole lot of difference in this application. Okay, now how many of them do I have? I have 3 of them. So you're going to type 3 and hit what type of insulation? THHW. So look at the one that I'm going to hit. Hit THHW. So I have, it takes THHW and shows it as THW, guys, but don't worry about it. The calculator takes the two THW and THHW together. So, okay, when you're there, don't go anywhere. Because they're different insulated, they're different type of wire, one more step you need to add here. Click on it one more time. That will give you the area. Click one more time. You should see the area. This is crucial step in using the calculator. Because we have more different sizes, you have to put the number, and after you hit the number, hit the THW again, so it gives you the area that's going to occupy. That's the area that's going to occupy. When you see the area, let's go bring another conductor. Okay, everybody saw the area? Let's go bring the other conductor. 400. All right, so let's go to the wire size, right? Everybody is at the wire K. Don't forget the K. A wire size. How many 400 do I have? I have one conductor. What type of insulation? THHW. At this point, Chris, I need to hit one more time. So it gives me a fill for that particular conductor. So remember, now I have 4 conductors. 3 of them that added together and one by itself. Make sure you hit again. Everybody got that number? One more to add. And I can keep adding as many as I want, but I need one more, the ground. I need to do my ground. So what's my ground? My ground is number 3. So here's number 3. You hit 3 and you hit wire size. Okay, how many number 3 do I have? I have only 1. And THHW, click here and make sure you click one more time so it gives you the cross-section area for that particular conductor. Cool? Alright, now I'm ready to get my conduit. If you go hit conduit, it's going to give you a 3.5 PVC. We happen to have been in the PVC. By the way, if you're not on the PVC, you keep clicking. Let's go EMT now in a second. So I have a 3.5. Is that cool or what? Talk about fast. No, nothing. You don't have to do any calculation. Okay. So suppose your boss yelled at you and he said, no, I want rigid. I want rigid metallic conduit. So what do? Don't change anything. You're going to go set and change this one to rigid. And there's a method of better than that, guys, with a number. I can't remember the numbers. I should go to it. Here's EMT. You can get 3-inch EMT. ENT, good luck finding a conduit. So you keep going all the way. What did we say? Rigid. Here's intermediate. You need 3. If it's intermediate, and if it's this one, good luck finding a size. The same thing. And where am I here? Okay, let me go. What did we say? We need rigid. Rigid metallic conduit, 3.5. PVC was also 3.5, right? Schedule 40. Let's do PVC Schedule 80. Let's try to see PVC Schedule 80. So keep going until you hit 80. 3.5, 2. PVC Schedule 80, 3.5. Any question, guys? Can you see how nice you can flip between conduits right on the spot? Any question? Any question? So the only disadvantage of the calculator, obviously, if you have a special installation like RW or different type of installation, PFA or MPW or a couple of other installations, might not work with it. But again, it will cover 90% of your application.
They'll let you use a calculator like this for the exam.
Electrical exam?
Yeah, use their calculator.
Master electrical exam? No, we're still in the 60s. In my book, if you ask me. If you know how to use this calculator as an electrician, you're more valuable to CA Electric where I work than somebody who's no. They don't. They allow you to use even a scientific calculator in Minnesota. They allow you to use a calculator that,
They provide it, or?
yeah, they provide a calculator. It's a simple one that has multiplication, addition, division, and square root. So, but I see you emphasize the basics, but if you're an apprentice and you know how to use this one, there's some skills involved in doing it. I mean, you guys all know how to do the calculation. You have done it by hand, right? Everybody knows how to do it. Now we move to the next step. Do it by hand instead of doing it right, doing it fast. Right and fast. Okay, any question, guys, about this? Any question? Any question? I'm going to give you 5 minutes, and I have a few other things about the conduit fill I'm going to do. And again, as you can see, I'm looking at it from a completely different view. Giving you the example right on the board. So let's take 5 minutes. Now there's an example about a nipple, which is 24 inches. I want to remind you, you can't do this one on the calculator, but you know how to do the math. You do it, all what you have to do, all the same calculation. The only difference is you go under 6-degree column. That's all. So I'm not going to do an example like this, but here's what I want to highlight, guys, before I leave this, and I assume you're going to carry it with you as we go through. So all the way, we got all the conduits. Moving on, we highlighted my conduits. Okay, the second thing, so chapter 5, or table 5, the other one I want you guys to know is table, so we know how to use the cross-section area from table number 5. Now, what is 5A? Have you guys used 5A? Anybody ever used 5A? Compact conductors. What the heck is it? Anybody knows what a compact conductor is? Compact conductors? Compact conductors, they make them in a way, yeah, they make them so close to each other that the space between the strands is, there's no, almost tight together, so tight that for the same 4/0, it's smaller diameter. If you say take 4/0 compact versus 4/0 non-compact, the 4/0 compact would be smaller diameter, smaller cross-section area than the non-compact. Who cares? Where would you use them? Expensive, you're not going to use them except retrofit. So take this, Zach, you have a conduit, 4-inch conduit here, and you outgrow your 4/0 conductor, and you need to go now to 300 kcm. And you can't fit the 300 kcm in the 4-inch conduit or whatever. So what do you need to do? The regular, you go and buy special conductors, that's called compact conductors. And that's where they use for these. They're going to look something, aluminum on cover, guys. If this is the strands, they look something similar to this. That's how the strands, they make it the strands, so they can fit. Can you see that? Versus, this is compact versus non-compact. Non-compact will look something like this. See how the conductors are non-compact, round. These are stranded. Of course, we're talking about stranded conductors here. I hope you understand. Okay? Compacted, non-compacted. Who cares? You don't have space between the strands, and you have a smaller diameter for the same size, which means you can fit more conductors in the conduit, more than normal conductors. So take this. Let's do this. Suppose I have THHN, the single most important insulation that I'm going to be encountering, and I want to remind you guys it's for copper as well as for aluminum, right? For copper as well as aluminum, and so that one, so let's take, I like 500, so let's take a 500 here. Here's my 500. My 500 for THHN conductor, 500, the cross-sectional area, approximate area, cross-sectional area is going to be, what is that? The first right in here. And if it's XHHW, it's going to be this. And if it's TH or THHW, any one of these, it's going to be right in here. And you guys can see them in your machine. 6.9, 0.6939, 0.6151, 0.6082. Now, can I do compact on this calculator? No. So put the calculator out if it's special. When would you use a compact? At least you probably will encounter this compact, I'm going to say 5% of the time in your career. 5% of the time. Just be aware that there are conductors that can fit in a conduit. Only retrofit, expensive to make the whole. Can I make all done with rewired with compact? Will be expensive. Okay, cool. But I want you to be aware. How do you do the calculation? The same way, guys. So suppose I have 4 conductors and the insulation is THHN. What do you do with this? You multiply this by 4. Right? And you do the same calculation, same time. So what's the advantage, Phil, my friend? You can get a smaller conduit to fit the conductor, or you can fit bigger conductor in the existing conduit. Most of the time, the conduit exists, and we need to fit bigger conductors in it. Because we outgrew the load is bigger now, and we need to pull main conductors. Not a whole lot of deal, guys. Most of the time, when you outgrow a load, you pull a new cable, a new conduit, and so forth. That's the best way to do it.
Do you have the key for the big closet? I need to get food out there.
Yeah. Give me a second here. Okay. Any question? Any question about using the compact? Straightforward, exactly like 5. So when you say compact, please don't use compact conductor unless it tells you, unless you know that you're using compact conductors. Copper or aluminum? Any question? Okay, so that's easy to make a calculation for that one. Just for the heck of it, I would like you to do this one for me. 4 conductors. Can you guys do the math for me here, please? 4 conductors times THHN times 0.6151. Can you give me the answer? Let's go find an EMT conduit to fit it. See how big of the EMT conduit. So can you take 0.6151 times 4 and give me the answer? No, it's different now. This is compact. Yeah, you might have to put, I guess you can put the cross-section area, 0.6151. Anybody? So 4 times 0.6151.
2.4?
2.4 square inch.
No, I'm sorry, Ed.
It's all right. Any other?
Close.
What is that? I need 2 people to agree on that one. You guys want 10 out of 10 in the participation?
Oh, it's 2.46.
Okay, 2.46 with not square inch. Okay, so we have 2.46 square inch, 4 conductors, 500 kcm, THHN. Let's go, guys, find a conduit for it and see how big of a conduit we can get. This is, remember, it's compact. Let's go EMT. Oops, don't want to do that, Chad. That will get me way out of my comfort zone here. Okay, let's go to, what do you say, EMT? Here's my EMT, up to go. All right, so, okay, so what did we say? Do you remember it?
2.46.
2.3 here, 2.46. Okay, 2.46, 2.4, so I have to use this. EMT it. I'm doing EMT, so I have to use, right, 2.3, 2.4, so that will give me number 3. Number 3. You guys remember the first, how much did we get when we have 4 conductors, 500 kcm THHN? Remember what we got, 3.5?
Thing.
Was it 3?
Yes.
Okay. So we didn't get a whole lot in this because of the number of the conductor.
Would this be considered one wire though?
No, there are 4 conductors, compact.
Well, I mean, okay, so
They are 4 single conductor cables. Any question, guys? So we have 3. I can't. And we had our example before. Let me grab. We got our conductor for 5. I can't remember what we had. I think we had it here. Okay, 5 conductors, 3 inch. Yeah, we came with the same answer. So the reason probably because of the number of, there's a whole lot of factors. But it's supposed to get you a smaller conduit if you're to use it. Okay. All right. Any question, my friends? Any question about that? Before I go to a different part. So we did compact. Let's keep going all the way now. I want to highlight 2 more tables, and then we'll be done with this. Make sure that everybody knows it well, knows how to use it. We did the compact here. Okay, table number 8. Table number 8, if you have not highlighted this, please do so. Table number 8, guys, we're going to use it for two factors. Table number 8. We're going to use it for when we size voltage drop, and also if your conductor is bare. Okay, suppose I have, let's suppose I like the 500, so I'm going to go to the 500 kcm. Oops, 500 kcm. Undo. Okay, so I'm going to go to my 5. I don't want to do that, Chad. Why is it doing it here? Undo for me. Let's go right to left. It keeps doing it for me. Okay. All right. Not Mati. Okay. So I have. There you go. I have 500 amp, and what I want you guys to highlight here is the cross-sectional area uncoated. The cross-section area, if that was a bare conductor, oh, I should do that one, Chad, undo. So I have this. This is table 8. Table 8. Table 8. There you go. Table 8. So, and that's the first one, uncoated ohm, the power, and the cross-section area that you need to highlight here. So take this. If you're pulling a 500 kcm bare conductor or covered, no insulation, that's the cross-section area that you're going to be using, guys. So very, very important. My cross-section area for 500. Only if it's bare or covered, you use this table. Cool? Number 2, if we're using voltage drop calculation for copper, we're going to use, here's my kilofoot, and this is my, we'll talk about this one later when we do voltage drop. That's my resistance, DC resistance for the voltage drop calculation. For copper, if we're doing aluminum, obviously this will give me the aluminum conductor size, the resistor. This is how we use this table. Any question? From a conduit fill point of view, guys, that's the only important number right now, right in here. Conduit fill point of view. Any question? Any question? Now the question would be for my friend Phil. Say, can I use a calculator for this one? No. How often do you pull a conductor bare or uninsulated in a conduit? The only time you can pull a bare or uninsulated in a conduit if it's an equipment grounding conductor or bonding conductor. It's the only time you can.
So if you have PVC, for example.
Yeah, you can pull an, yeah. But it's the hardest thing is usually you pull a conductor, an insulated conductor, and you use it most of the time. But that's the only way. PVC, bare conductor for equipment grounding conductor or bonding. Okay, so got that one? The last thing, my friend, and we will get into the AC resistance as we go through. So there's a table, table 9. We'll get to it later on. But I'm going to go all the way to Annex C, guys. Annex C. And that will be it in terms of conduit fill, voltage drop, all this good stuff. Annex C. Let me see here if I can go faster. Okay. Annex C. Okay, can you guys go to Annex C? If all your conduits are the same, you don't have to mess with everything that Chad have just said. You're going to go to Annex C right on the spot if you have not done that. I want to remind you, this is my friend Annex C. So if you haven't highlighted Annex C, please do so. I want to remind you of two tables. Table, this one here. This one is EMT. And what's the difference between the EMT here and the EMT right underneath it? And the little star next to it. The one underneath is for compact conductor. Do you guys remember the compact conductor we just talked about? If you want to find how many compact conductors, if you have 500 kcm conductors, 4 of them, and what conduit EMT you need to fit them in, you're going to go to the lower one. You're going to go to the lower one, right here. Any question? Any question, guys, about that? So if I were you, I would highlight all these, my friends. These conduits, especially EMT, you need to highlight EMT because you're going to be in it a lot. You need to highlight PVC. I always highlight PVC Schedule 80 and PVC Schedule 40. These are rigid or intermediate. These are the most common ones that if I were you, I highlight them in my text, and rigid here because they use rigid. There you go. These are the most common ones. You probably have to highlight them, and it tells you where they are located in the code if you have not highlighted these. Okay, let's take an example. Very easy, straightforward. The good thing now, the calculator work with this. So you're going to see how fast. If I ask you, I have a 5-inch rigid. How many conductors, 4 I can fit in it? THHN. Piece of cake. Let's take an example or two here. EMT, since 90% of the time probably guys are going to be in EMT, let's go directly to EMT. Here's my EMT, right? Everybody knows where we are. C is EMT right here. Highlight my EMT. Let's go to the installation dear to my heart and dear to yours probably. Let's go to THHN. Here's my THHN. Let's go down here, here, so we can see the conduit size. Okay, THHN. All right, THHN. Okay, so here's my THHN. Can you guys see the THHN? And in an EMT conduit, suppose I have a 4-aught, and how many conductors can I fit in a 4-inch EMT if all of them are 4-aught? 18 conductors. 18 conductors. Cool? 18 conductors. They're THHN. Any questions about that? 18 conductors. I can put 18 conductors 4-aught in a 4-inch EMT conduit. Not that I would do that. So let's go do that on the calculator. You guys have your calculator handy? You have a calculator handy? Let's go across that. Make sure clean it. Okay, what size? Now I'm looking for what am I looking for? I'm looking for an EMT conduit. So make sure. Let's go right away. Set my conduit to EMT. It's not set to EMT here. So I'm going to go. If you guys use the manual in page 51 of the calculator, there is an easier way of jumping to where you want. If you want EMT, it will tell you hit 1. If you put 1 through 12. There are 12 conduits here, and they number them 1 through 12. So if you're looking for PVC 40, you hit 10. So I'm going to use EMT. Look what I'm going to do, EMT, to go directly to EMT. Hit 1 and set and conduit. That will take you directly to EMT. Just to set yourself at EMT conduit, right? 1, set, conduit. That will get you into conduit. Okay. Now, what's my question is 500. I need what was it, guys? I have what was my size? I have 4-aught. How do you type 4-aught here? 0, 0, 0, 0. Here's your 4-aught. And wire size. Then how many of them I need 4-aught? Now I need the conduit size. I don't need the number. I need the conduit size. I don't need the number. I need the conduit size. So first of all, put 0, 0, 0, 0, cover. That's a 4-aught N. Now let's go put the conduit size. What conduit size do I have? 4. So hit 4. And instead of putting 4 wire now, you're going to put 4 conduit. 4 conduit. Remember, we already set the conduit at EMT ahead of time. 4 conduit. Okay, what's the installation then? THHN. Then just all what you have to do, go to hit THHN, and guess what you get? 18. Did we get 18 here? Slick. Very slick. Any question, guys? Any question?
Yes.
Any question? Very slick. Very slick. So you can find, if you have a conduit, when you see how many conductors. Now here's what gets even more interesting sometimes. If you hit twice, it will tell you the cross-sectional area of all these conductors together. If you hit one more time the conduits, give you 18 of them. Hit another time, will give you, this is 5.8266 cross-sectional area. So later on you can add, if existing conduit, you want to add a conductor, you can find a cross-sectional area. So it's very helpful. You go to the conduit. The conduit is well, we have to, okay, so I just flipped it. Any question, guys? Shall we do one more example on that one? Let's do that. Let's take THHN. My favorite is a 3/4 of an inch. Can you guys see? We're still in EMT, 3/4 of an inch.
No, we're in compact.
No, we're not compact. We're non-compact. So I want you guys non-compact. We're not doing compact. So let's go to THHN. Where's my THHN? Number 12. Do I have THHN in this? Where's my THHN? Okay. Okay, THHN. Go all the way to THHN where we were. I just want the conduit size. Okay, take this. I have THHN. How many conductors, number 12, can I fit in 3/4 of an inch? How many conductors, number 12, can I fit THHN in 3/4 of an inch? 16. Right? Let's go do it. So let's go. The conduit size is what? What's the conduit size? 3/4 of an inch. So it's going to be point. You put it as 0.75, right? 3/4 of an inch is 0.75. 0.75 conduit. So I have a 0.75 conduit, which is 3/4 of an inch conduit. EMT. Okay, what's the conductor size? I have 12. So hit 1, 2, and hit wire size. That's 12. So I have 12 conductors cover into the calculator and a conduit of 3/4 of an inch or 0.75% or 0.75 inch. Now with the conductor that I need is THHN. So hit THHN, 16 conductors. You can put 16 conductors, THHN in 3/4 of an inch. This is very powerful when you pull your branch circuits. It's how you pull branch circuits for lights and receptacles, right? 3/4 of an inch, 3/4 of an inch conduits, and you pull your conductors right into it, number 12. Now suppose you change your mind, it's not THHN anymore, it's XHH 11. No problem. Clicks on XHH, it gives you 11. You might have to go down, guys, to find the XHH. And if you go THW, it's also 11. Can you guys verify that THW is 11 too? Let's go verify that one. We need THW. What do you call it? I need THW. So I think it's at the top here. THW.
THW doesn't come in size 12.
THW. It should. THW right here. Right here. Do you see it? Right in here. Oops. Oh, undo, Chad. You see it?
Oh,
Right here. Here's my THW. Here's now my number 12. And what was the size they said? 11. Why didn't it give me 11? Am I in compact? Where's my 3/4 of an inch? 3/4 of an inch. They didn't give me 11. Interesting. So number 12, it gave me 8. Number 12. What's the other one? Did you get 11? What am I?
no, on the one I before.
Yeah, yeah. Yeah.
What's where exactly where it got at?
Am I looking at the wrong one here? THW. Okay. We're looking at the right table. Yep, it's not the compact one. Interesting. For the THW, are we looking at the right column? Right column is 3/4 of an inch. Yep, 3/4 of an inch. So THW, number 12. Okay. How about THHW? How much THHW? Do we have THHW? We don't have THHW. THHW. Here's I don't have THHW with this size.
Comes up with 8.
8. Yeah.
That's a good.
Interesting. Well, here's an email. I don't know what they took. We did it right. Let's go do it one more time just to make sure that we did it right. Okay, clean that one. The question was if my conduit is my conduit still EMT? Up, it's EMT. How many conductors did we say? My conductors are 12. Here's my 12 wire conductor. And my conduit, what did we say the conduit again? Point
Is 0.75.
75, 3/4 of an inch, 0.75. Here's my conduit. Perfect. I need to find THW. 11. Interesting. Okay. I know it's good for the THHN anyway. Still doing 11. Let me check on. Are we missing anything here? Why is the code is giving you 8?
Are you sure you're on the right,
Should be.
you're on, that star indicates, contact.
No, we're here. I am in maximum number of conduits, not a star here. See it?
Okay.
Yeah. Are you? Where are you? Are you in that one? And I have THW, right? 4, 8. 12 will give you, if it's TW, TW will give you 11 for number 12. Interesting.
Can you show me that table name again that you're on?
The top, yeah, here you go.
We're in Annex C.
Annex C.
C1.
Yeah. That's interesting. Okay. So THHN works. THWN gave us a different number. So that's all what I want to show guys in terms of conduit fill. Any question about that? Any question about the conduit fill? It's now that I'm curious to make one more calculation for. Let's do that one here. Nick, do me a favor. Let's use an inch and see if that will work with THW. I'm just curious as THHW. THHW. Let's see. Here's THHW. And there's number 8 and an inch, right? If you put it, this is an inch.
19.
Is an inch. So give you number 6. 6 conductor in an inch. Okay. Let's do an inch, right? So let's see. Try it with an inch this time. All right. So here's 1, and here's an inch, right? And I need number 8. Here's my number 8 wire. And I need THHW. Here's my THHW. Number 8, not number 6. Interesting. For number 8. Okay. You see that? All right, disclaimer. Any question guys about this? So you know how to use them. I would probably be caution you to use it for THW, THHW. We'll try them with another version. Any question about conduit fill? Any question about conduit fill? I want to do an example, guys, that can't be done by the calculator. Okay, here we go. There's an example about wireways. Wireways is the respected. Let's take an example about wireways. When I'm way out of whack in my coordination here. Okay. Format insert. I need to coordinate myself. All right, we'll do that. We do coordination for my. All right. Let's take this one for wireways, guys. Why does it want to work with me today? Let's take its time. Too many things open.
Know what's going on. This calculator, as well as the tool I made, is doing the computation based on the percentages.
Yeah.
table does not. There's an error, either an error or a decision in that table.
That's giving you different things. It's good. Good to know. That's what. Okay. Let me take this example, guys, please.
So the bottom line is, if you want it to match the table,
THHN.
they will have to do a discrete lookup rather than a computation.
Yeah.
And maybe a couple in the table.
Yeah, I have to try. The jury's out. I haven't used it before. But I want to do this example, guys. Example. Wireways. Wireways are well-respected wiring methods, and I'm going to take an example of how to size a wireway, guys, for a bunch of wires. If you have a wireway, how can you size a wireway for a bunch of wires? I want to take
What's the wireway?
a wireway is like a surface, exactly like this one, surface-mounted raceway, except it comes in a standard sizes, square standard sizes. Okay, wireways. We will talk about number of conductors. This will be covered 376. This article 376. My intention is not to talk about where you use it, guys. You can pull a wireway right here and feed multiple motors on the table from it. So let me just draw a panel here. Pull your wireway out of that panel, and from here you can feed multiple equipment from that wireway. Multiple equipment with conduit. So this is my panel. This is a switch. These are all disconnects, and from right in here you can feed multiple motors. And inside it, you can have all the wires that God created sized, coming and fit from this panel. So this is what we're sizing. That's my wireway. Now, how do we size a wireway? Let's go size the wireway based on the code. There are a few things, guys. I want to use an already calculation so we don't have to do all this this math and stuff. So let's say, first of all, they come in a square. They are a square. The cross section of it is a square. The length, you can buy them as many length as long as you want it. I think they come in 10-foot sections. So let's go size a wireway. Okay, so here's my example. My example is, I have the following, and I'm going to use it directly here from the book, so I don't have to do the calculation. I have the, or you'll help me with the calculation here. See, let's use, I like 500 kcm, so let's use 3 conductors, 500 kcm, and 1 conductor, 300 kcm, and 1 ground, number 3 kcm. Let's make all of them THHN, 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 THHN. Okay, so 500 THHN. Can you guys give me, when the question is size a wireway to fit these in a wireway, not in a conduit, wireway, piece of tape. The first thing you need to do, guys, is you take the number of conductors. So for the 500 kcm, you're going to go to table number 5, right? And from there, remember it's a THHN, and I have 3 of them. Multiply the 3 by, what's a 500 kcm? 500 kcm, I have it here. 500 kcm THHN at 0.7073, right? 0.7073. Is that right, Chris? 0.7073.
Oh, you're looking at
The cross-sectional area.
size of
A single one of them.
Yeah.
Okay? All right, so let's go to the second one. So this is number 1. Number 2, let's go to the 300 kcm. Chris, I have 1 of them. What's the cross-section area of 300 kcm THHN?
0.4608.
0.4608. Anybody disagree with Chris? Agree? Okay, the last one, guys, is number 1. And that would be 1 times, what's number 1, Chris? THHN?
Oh, it's, 0.097. Oh, it's,
0.09.
yeah, I've got the wrong size on here.
Did you? Okay, let's go to the table then.
It's 0.1562.
0.1562. 0.1562. Add them all up. How much? Is it wrong? 3, 1. Oh. I'm sorry. Yeah, let's do that number 3. Sorry. Can you give me for number 3? My apology, because I put number 3 there.
0.0973.
Multiplied by 0.0973.
73.
Okay, what's the sum?
2.680.
2.680 square inch. Up to this point, guys, if I ask you to go size me a PVC or rigid conduit, you can go size a conduit right from table number 4. No question asked. Except we're not asking about a conduit. We're asking about wireways. Up to this point, the calculation is the same, right? Exactly like conduits. Now let's do a little bit of change to make a wireway. I will remind you, wireways are square. That's the key point about them. Any question up to this point? Add them up, we're going to go size a wireway. Okay, 2.680. So I go down here to 2.680. That's the size. Now from my size, for wireways, guys, you can't fill the wireways for number of conductors in the wireways. 376.228. 376.228. If you go there, it will tell you can't fill it more than 20%. So this is the rule for wireways. Write this rule for your wireways. You can't fill more than 20% of a wireway. So what would you do? This is conductor area. This is your conductor area. I can't fill more than 20%. So to get the full 100% of the wire, you divide this value. So wireway size, take the 2.68, divide this by 0.2. Why did I divide by 0.2? Because 0.2 represents 2.6 square inches. What is 100% square inch represent? If you do cross multiplication, you end up with taking this number, dividing it by the percentage, 0.2. Chris, what do you get?
2.536.
0.5 should be more than
I'm
that.
sorry.
I got 13.4.
13.4.
Yeah.
Okay, 13.4 square inch. Okay, so that's the size, the cross-section area of your conduit. We have an issue though, the wireways are square. So if this is X and this is X, the dimension, so it becomes X squared equal this value, 13.4, right? Because it's a square. So what is the dimension of it? I need to find the X and the Y, or the square. It's a square. So I want to find, is it 2 by 2, 4 by 4, 5 by 5? So how do you solve this one? X equals square. Long story short, you're going to take the square root of this number, 13.4. What's the square root of 13.4?
3.66.
3.66 inches. Here's a moment of truth. You're going to go custom, you design yourself a 3.66 by 3.66 wireway, or you're going to go to the next standard. If you don't know the next standard, just go to the next whole number. So what would be the next whole number for this? 4 by 4. So this will be a 4 by 4 wireway. If they make them. 4x4 wireways. I believe they make 4x4s, 6x6 and 4x4s and so forth.
Are they listed anywhere in the?
DeWalt, I don't know if DeWalt lists them. Let me check that one, wireways. I know they do a few things, but can't remember. Okay, where's... Okay, busway, duct, circuit breaker, size of gutters. Oh, wireways, yeah, you're right. Here, it's 4x4. The actual size is coming from 3-12. Should remember that. So you guys go to DeWalt 3-12. If you go to DeWalt 3-12, they'll get you 4x4 wireway. So it's 2.5 by 2.5, 4x4, 6x6, 8x8, 10x10. And I'm sure they custom design anything you want if you are willing to pay. Any question, guys, about how sizing a wireway? The key point, William, my friend, is you do the calculation as if you are sizing conduits. You take the number divided by 0.2, which is the 20%. Up the number, but the number becomes big. Take the square root of it because I'm looking at a square shaped wireway. That's why we took the square root of that number. And then you get up with the number so that then your conduit will be a square conduit, 4x4, 2x2, 3x3, and so forth. Any questions about that? Any question?
Now we're taking 20% of the area used. Don't you take 20% of the?
There's the actual area. The actual area that we did here is 4x4. This is looking at it.
No, I'm sorry. We're taking 20% of 2.68.
So where your conduits are going to be sitting, your conductors, how many of them do I have? 3. 1, 2, 3, 4, 5 of them, right? My conductor will be filling this area here.
Yeah.
So this is the 20%.
Question is, why are we taking 20% of 2.68?
20% of 2.68. 2.6. We're not taking 20% to 2.68. We're upping. It's doing it in math, guys. Here. Yeah, you can
multiplying it.
You can what is it? 2.68. 2.68 represent 20%. X represent
20% of what?
Of the area.
Of the area of what?
Of the wireway, the cross-section area of the wireway.
Okay.
We're looking at a cross-section area of a wireway, like conduits. So if the 20% represent 20%, what value represent the 100%? I hate to do the math, but if you do your math here. So x cross multiplication, right? So x equal 2.68 times 100. That becomes times 1 because 100 of 100 is 1 divided by 20%.
Now you answered the question.
And that's exactly why I said cross multiplication, or you divide from the beginning by 0.8. Because 20% of the cross-section area represent only 2.68. What is the whole area though? I'm looking at the whole area so I can size the wireway. Make sense?
Yeah.
So that's what I said. You take that calculation I did, just divide it by 0.2 or 20%. And that's, of course, 20% is 0.2 is 20%. Any question, guys, about this? Let's do one more example about wireways because they're new. Example number 2. You can't do wireways with this calculator, and we discovered that the THW doesn't work. What else we're going to discover? We'll see. I need to try a couple of times though. Okay, let's say
If the code says that your you're doing it by formula, then the
right.
calculator's right and the table's wrong.
The table is wrong. If you go by table 5 and table 4
You
calculation.
go by the mathematics, and
Yeah.
say you can use 41% of the square, of the area,
It's right.
then
Number 11.
this is correct. And
So Annex C, what you're saying is Annex C could be wrong. That's a good
yeah,
point.
I mean, if it's supposed to be derived by formula, then it is incorrect.
The way I understand it, if you do the calculation based on Annex C, it should match the same calculation that you get from table 4 and table 5. If all the conductors are the same, they should match. If they don't match, they should match. Then there's I bet you that's why they're using table 4 and table 5. So, to be continued on that one. Okay, let's take another set of conductors, guys. Take a wireway. I have a nice wireway, and I decided to load that baby with a 20 conductors, number 12, THHN, 10 conductors, number 10, the same thing, THHN, and 3 and 4 conductors, number 4-aught, THHN. Is that enough or what? I decided to put all these conductors in a wireway, and I'm asking you politely to size this wireway for me. Size the wireway that can fit all these conductors. So what's the question is, wireway size. Typical. What is the wireway size for this baby? Okay. We'll start with number 12. Number 12, my friends. Number 12, when you go to table number 5, under THHN, I have 20 of them. Chris, what is the cross-section area for number 12? You have it? I just want the cross-section area for one.
Okay, so one of them is 0.013.
That's it?
Yes.
Okay.
And number 10 is 0.02.
1 second, take it easy on me. Number 10, I have 10 of them times
0.0211.
Thank you. And the last one is number 4-aught. 4-aught.
0.0824.
0.0824. Anybody disagree with my friend Chris? Anybody dare to disagree? No, you get him. No. Any question, guys? So these you get them directly from the table. I assume where you got them from your calculator, so they were coming from the table anyway.
Wait a sec, the last one was 4-aught, right?
4-aught.
Oh, 4-aught.
Oh,
Okay, that should be point.
Not number 4, but
no, 4-aught.
Oh, okay, I saw number.
Okay, no big deal. They put number 4, 4-aught.
0.3236.
36. 0.3236. Perfect. Add them up. What's the sum?
1.772.
Square inch. The sum is 1.772. Up to this point, guys, I can go size right now. I can go size any conduit to fit these. I don't want to put them in a conduit. I do not want to put them in a conduit. I want to put them in a wireway. Okay, I'm going to wait until you write these. Okay. Move. Okay, 0.1772, right? Is that? So my area is 1.772. Okay. My area is 1.772 square inch. Okay, so this is the area of conductors. The area of the conductors. Wireway area. The wireway area, guys, as we said, you take this number 772 divided by 0.2. We know why by 0.2 because we can't fill more than 20% of that conduit. So what would that answer be? 8.86 square inch. Now the area equal 8.86. Then the dimension, which is x of that conduit, have to be what? Square root of 8.86. What would that give you? 2.97 inches. And taking this one to my friend DeWalt, right here, do we have 3? We don't have a 3 directly from DeWalt, so take this 2.97 inches, take it to DeWalt, which table and where? 3-12, and that will get you the next standard, will get you a 4 by a 4 inch. 4 inch by 4 inch wireway. Up it goes. So your wireway size is 4 by 4. Any question, guys?
So the minimum is pretty much if you're below 4, then go to 4.
Yep. No, they have. I thought they have. They have 2.5 by 2.5. See at the top.
Sizing gutters.
Size of gutters and wireways. Do you see? Can you guys see them?
Oh, I was looking at the full box.
No, it's sizes. It's in 3-12 sizes gutters and wireways. That's a nice guide to the standard sizes. Any question, guys, about the sizing of wireway? There is an issue with wireways, guys. If you go, I believe, more than 30 carrying conductors, you have to start derating. So there's derating issues. We'll do derating when we get into the derating with wireways. We're now interested in fitting them into the wireway. We're not interested in the derating. So take this, Chris, my friend, your beautiful wireway that you installed. Here's my wireway. Only 20% of it is occupied because of heat and all this good stuff. The rest of it is 80% of it is not occupied. Looking at it from a cross-section area, ease of installation, heat, bunch of other things, and we'll talk about the carrying conductors and derating for wireways as we go into next chapter.
Do they oversize that because they lay flat rather than flush?
Well, you can group when you pull them in there, you can group them together.
Yeah, I mean, you have a lot more surface area.
Yeah.
Well, right, and
Yeah.
a lot more air. You think
And you can open the wireways open, so you can open the wireway and pull your conductors. You don't want to jam them. They want you to jam more than 20% of them. On the other hand, surface-mounted raceways, guys, they allow you to do a lot on them. But if you do more than that, then you have to derate. You start derating. There's some derating issues. We'll get into that one as we go into the derating. Wireways versus raceways. Any question, guys, about conduit? Yes, sir.
what do they use for the rest of that area?
What do you use the rest of that area? The conductors are not going to be jammed. They're going to be, guys, sitting there all over. So when you look at a 20% full wireway, it looks fuller than its actual square inches. You know what I mean? Because you look at the wires, they don't sit smooth like you see. When you pull them in a wireway, as you tap them and all the stuff, they don't. They're round. There's space between them, so they look more full than what the calculation shows. So, but if you jam them 100% and 80%, then you heat issues. And a bunch of other issues that could happen. So the rest of the area is sitting there, empty. Heat dissipation, ease of installation, and all this good stuff. Any question, guys?
What prevents people from throwing more conductors in there?
What prevents people from throwing more conductors in this conduit?
Yeah.
Right? Here's a conduit full. What prevents me from adding more conduits? You would hope people will do the right thing, but
If it is.
yeah. And by the way, guys, there's a lot of safety factors. Take this. If you go load this conduit instead of, what did they say, 40%? If you add it if you add 60% to this conduit, jamming, the system is not going to fail. It's not a good system. It's most likely at one point it could fail if it's overloaded and so forth. You could damage the insulation. You could. It's like when you drive, you could get into an accident if you go speed and reckless, but you could not too. So that's why we err on the side of safety when they say 40% fail. So if you go and you fill it really 50%, do you think your building is going to burn? Absolutely not. Any question? That's all I have, guys, about the wireways. I don't want to start the conduit box fill and pull boxes. I want to do it tomorrow. We spent good time on it. So the rest of the day, guys, I would like you to start, if you haven't started your low voltage, start laying out your low voltage, and I would like to redline lighting for all of you guys, the ones who I have not done that yet. Thank you.